this video, we're going to look at lesson 6.03. So, in your probability distributions, you're going to have different types of notation. So, for example, if you have P parentheses x equals 1, this means it is a probability that x is equal to 1. Okay? And this next one is a probability that x is greater than 4. Or you could have the probability that x is less than or equal to 25, or that it is, or it could be a number of things. This is just how you would read it. The probability that x is greater than 1 and less than or equal to 6. Okay, and then here's the last one, the probability that x is equal to 10 or greater than or equal to 15. Okay, if they're not together, then it's an or. If they are sandwiched together, like the second to the last one, you would put an and. Okay, that's just how you would kind of read it. If they're together, it's an and. If they're separated, then they typically put or, but it's an or statement. Alright, so let's look at these in practice. Probability that x is less than 2. It would be that one. Probability that x is less than 2. Now, if you have the probability that x is equal to 2, it would be a probability that x is equal to 2. Now, the probability that x is greater than 1 and less than or equal to 2, it would be this one. Now, the probability that x is not equal to 2, well, then you would indicate not equal to by the equal sign with the dash through it. So that means not equal to. And then, let's see, we've got two more. Probability that x is greater than 1 or less than or equal to 2. Well, looks like it's that one right there. Then the last one's probability that x is greater than or equal to 2. Well, that would be the last one left. All right, so let's look at the probability distribution table. So they're written out like this, where the first part has an x, and then you have p of x. So x is just the number of times, or whatever it's talking about. And then, in this case, it's the coin flips. So it is the times that you get a number of heads is recorded. So 0 would indicate no heads, 1 would indicate getting 1 head, and 3 heads, 2 heads, okay? And then you've got the probabilities at the bottom. So you get the probability of each one of those happening. So if I wanted to get the probability of at least 1 head, then that would be the probability of 1 minus no heads. Okay? So you would write that as 1 minus an eighth, because you would get that 1/8 from the probability of no heads. Okay? The probability of at least 1 head, so it's 1 minus 8, so you get 7/8 overall. Now that is one way you can think about it. Or you can think about it this way. Okay, you can think about it this way. The probability of getting at least 1, okay, if I said give me at least $1, that means you have 1 or more. So that means you would actually add up, here, let me change my colors over here. If you think about it this way, you would add up each one of these. Okay, so that means we're actually adding up the probability of getting 1, 2, or 3. If the probability of getting at least 1 head means you're adding up the probability of getting 1, 2, or 3 heads. So, and look, you still get the same answer. Okay? So you can think about this either way. So the probability of getting at least 1 head is 1 minus no heads, or you can think about it as getting 1, 2, or 3. 1 or more. Okay? Alright, so here's another one. The spinner has spun, and we've got the number recorded at the bottom. So find the probability of the spinner landing on a prime number. Now, let's go back and review what prime numbers mean. They're only divisible by 1 and itself. Okay, so we got 2. Now, 1 is not exactly a prime number. We got 2, 3, let's see, 5, and 7. That's all of our prime numbers. So that means we would add up the probability of getting a 2, a 3, a 5, or a 7. So we would add those probabilities up. So the probability of getting a prime number is 0.4. So let's look at this example. The length of a checkout line at an organic food store during its peak hours is shown in the probability distribution table. Find the probability that the line will be 4 or 5 people long. So the probability of it being 4 or 5 people long, so the probability of it being 4 people is 0.35 or 35%. 5 people is 15%. So you would add those up. Take 0.35 plus 0.15, add them up so it's about 50%. So the probability that the line will be 4 or 5 people long is about 50% of the time during the peak hours. Next, instead of writing it as a table, instead of writing your probability as a table, you could actually write it as a graph. So you have a coin flip 2 times and the number of tails is recorded. What is the probability of no tails? That means 0 tails. Well, the probability of that is 0.25. I think I covered that. Yeah, 0.25 right there. So you just read the graph and it's 0.25. You're getting no tails. All right, here's one that's a little bit more complicated. So we have a surgeon tracks the number of surgeries performed per day and arrives at the following probability distribution. What is the probability that the surgeon's workday is light? That means 1 surgery. Or heavy, 5 surgeries. So that means we would take 1 surgery or 5 surgeries. So we would add up those 2 probabilities. Notice this one is 0.04, then this other one is 0.12. We would add those 2 bars up, essentially. So we would add them up and we would get around 16%. Okay, so you take the probability of you getting 1 plus the probability of you getting 5. So about 16% of the time, the surgeon's workload is either light or heavy.